So we've talked a bit about how we've talked about how to do the OAuth process. So we've talked about how to work through that. Today we want to start talking about something called the architecture components, which are really a new way to build Android apps. And really to architecture them and where to put the code. So we're going to start talking about that process and how that works. This is going to be, just a heads up, it is a pretty big shift in how we think about and how we build our applications. So traditionally, kind of what we've been doing so far is really sort of that imperative model, where we've been doing the building up the applications and kind of you think about and we want to shift towards a more declarative model, and you kind of think about that transition in the web world, from like jQuery, where we're directly manipulating the DOM, to React, which is what we did last semester, where we're saying, hey, here's how I want it to look based on the data, right? And rather reacting to the data. So indirectly, like you click a button, that triggers an operation, that changes the data. The change of the data is what actually triggers a change in the UI. So that's actually what we're looking at today, is kind of the React for Android kind of transition. So it's a pretty significant jump in the way we think about their applications. So you kind of want to be aware with that. Previously, if you look like in the textbook, this is actually covered in the textbook in chapter 10.1, but it actually is really so fundamental to doing Android development today that I think we need to really cover it sooner. I was having a hard time figuring out like where do we cover this, and so you might have seen a schedule change around this. I originally had thought, I'll cover it next week. And I actually had moved it to this Friday because of just realizing it's like, I can't wait till next week to cover it. I need to cover it maybe a little bit sooner, because it is that important and it is that much of a shift to how we think about the applications and how we build them. So I want to look at some of the reading material. We'll kind of talk through some of the theory and some of the things that are happening there, and how we're going to build this thing. And then when we finish this, I'll show you an actual hands-on like code walkthrough of the NPR Tech News. I've converted it over to use these architecture components, and it was a pretty big significant shift. So we'll walk through that, but it's worth mentioning that this does really change the entire way you think about Android apps. So let's start with the reading material there. So first there's a few articles that I put out for you to read. One was this guide to application architecture, another about the view models and LiveData, saving UI state, background threads. But the main three I want to look at right now are going to be these top three. Is what is application architecture? What is this view model, and what is the LiveData data class? So let's start here. So guide to application architecture. And if you're following along, you're going to pull that up at that link. And in fact, with the URL, you actually can maybe tell a little bit in the fact that this says Jetpack guide. Like this is the guide for the entire Jetpack project, which Jetpack is basically the new support library for Android. So virtually everything we do with modern Android development as of a few years ago is with this Jetpack idea. So that's where we get into like modern Android development, etc. So as I say, this guide encompasses the best practices and some of the recommended architecture for building your robust, high-quality apps. Like these are the things we need to be doing today. In terms of working with mobile, you talk about user app experience, typically when we're working with this, we're going to see things like activities. We've so far built apps with just one activity, but we will eventually be moving on to more than one activity, more than one screen. You've also got fragments, which are sort of mini activities or parts of an activity. Services, which used to be a way to run code in the background, and specifically used to be primarily the way that we would initiate code that ran when the user isn't running in the app anymore. That's been replaced by something else. Content providers is something that you can use to say get the user's contact list, which is out of the side of the scope of what we'll be writing, but is a way to provide data between different apps. And broadcast receivers historically was a way to receive system events as well. Some of those app components are not as prevalent anymore, so really what we're focusing on this semester is just activities and fragments. I used to spend more time on some of those other components, but as things have shifted, some of those other application components have become less important than activities and fragments because of different things that have occurred. So generally speaking, as they mentioned, those have to be declared in the manifest. Yeah, and this is a very important note to keep in mind, is that at any given point in time, because there's a limited amount of resources on mobile devices, there's a limited amount of processing power, a limited amount of data, there's a limited amount of memory. Because of those resource constraints, so resources being memory, data, and CPU usage, CPU time, your operating system can choose to kill your components, can choose to kill your activities or your fragments, or get rid of your views, etc., because it decides that, hey, I need those resources back to work on this other application. So you can't necessarily rely on those being around. So as they mentioned here too, it's possible, given all of that your components might be launched just one by themselves. Like you might have an activity further in the application that you only get to, through following XYZ screens. So it might be 5 screens in depth, but in reality, you might find that your application runs it where it just immediately skips down to that 5th screen and doesn't go through the other 4 screens before it. That happens. Other things that, or it may hit your components in a different order than you expect. So those can be issues and those can be problems. And so part of what we're trying to suss out and part of what we're trying to work through is these architecture components, which we're going to be talking about today, which help with some of those complexities and help kind of alleviate or hide some of those complexities so you can just build your application and have to work less with some of the oddities of Android and how that whole life cycle works. So, and as I mentioned here, largely the order, and there's a lot of things that happen here with things running out of memory or different applications running, etc. A lot of these things may be completely out of your control, or you shouldn't have dependencies around. So that's kind of the overview here. So as they ask you here, so if you shouldn't use app components, so we're talking about app components being our activities or fragments, to store application and data, how are we going to design our app instead, right? So because what we're trying to move away from is storing that data in our app, and specifically in our activity. What we've seen so far as we've been building these applications is that our main activity gets bigger and bigger and bigger and bigger over time because it's accruing the vast majority of the code that we write. Most of the code that we've been writing, all except for yesterday where I started to introduce retrofit and added some additional classes, we've entirely been building in that main activity. And that's a pretty common problem with the Android world, is that a lot of your code ends up being historically just in that activity or bound in that activity, and that becomes a problem, especially given that the activity gets destroyed if you just rotate the screen sideways. And so you have to deal with all sorts of problems because of the life cycle, as we say, of that activity. So if we can step out and we can step away from, putting as much code into the activity, that makes it easier for things to survive, and it turns out to make the program as a whole much easier to work with. So one idea in programming, and they mention it here, is this idea of separation concerns. The idea of separation concerns is a standard object-oriented sort of principle, and the idea is that different pieces of code or any particular piece of code should only be concerned ideally with one concern, right? Where we want to separate concerns into different files, different classes, different pieces or modules of our application. So one of the things in there you have to understand is, what is a concern, right? And I'm going to toss that out for Discord here to give people a chance to chime in. But I want to ask, what is a concern? You may or may not have heard this discussion. You may or may not have heard of separation of concerns before. But how would you define a concern? What jumps to your mind? And ideally, I'd like everybody to chime in on this. Okay. So a lot of your answers kind of center around, reading some of these off, we say potential problem that could be singled out or isolated. And, Evan, you're kind of on the right track when you're talking about isolated. Michael says a concern is something that can cause a problem in the future when you're adding more stuff, which you're also, that word future is part of the definition, is part of the picture, is when we're talking about concerns, we are talking about the future. And as Evan said, we're talking about something we can isolate. Chase said something that should be kept in mind is potential issue, which kind of falls into the next group of things I want to say. We're seeing a problem that can arise, Danny, potential problems, something that can cause a problem or can be singled out. So there's one issue here. This is kind of a common problem, is programming uses different lingo than English. So the word concern to a software engineer means something different to say your average person. When we talk about concerns, we mean something specific. So we don't mean a concern as in like, I'm concerned that this could occur. I've got a worry about something in the future. I'm actually talking about something else. So that's not the kind of concern that we are referring to when we talk about like the separation of concerns. But as I did mention, we're talking about stuff we want to isolate because our goal is to isolate these concerns, and it is about the future, right? David, you really hit the nail on the head when you said a part of your application that deals with one aspect like UI or database. So when we're talking about concerns, we're really more talking about maybe a part of the application or a piece of functionality. So what I mean by things like that, so for instance, there's the idea of how do I display the data on screen? Displaying the data on screen is often considered presentation logic. And so that presentation would be a concern. We also have things like, how are we going to store the data in the database? Database persistence is often categorized as a concern. So you got presentation logic, formatting, etc. is one concern. You've got how do I persist it to the database as a concern. You've also got things like, am I calculating tax correctly? Calculating tax correctly, that tax calculation would be a concern. So there's different areas. It's about delegating your problem or delegating your program into different parts, okay? And how you break those parts up is the hard part. In fact, there's a lot of different interpretations, I will say. It's not of what a concern is. It's not the English definition of concern, but even within programmers, there are several different interpretations of what a concern should be. The idea is that you can kind of think about it like a task or code that goes together, or different pieces that like part of the goal of breaking things down into concern is you really have to understand the goal is that if somebody asks you to go change code or add an additional feature, your kind of goal is to not have to change the entire program to change that one feature. Or if there's a bug in your code, ideally it would be focused and fall into one concern. So concerns are kind of one way to kind of bucket out bugs, is one way you could say it, is say, hey, these kinds of bugs should only follow in one concern, and so those buckets of bugs should also fall into a small bucket of classes that cover that concern. So there's a lot of different interpretations there. The other way you see it sometimes, we talk about layers. We talk about from the back end to the front end or middle tiers. So you might say like your database is a layer, and then you have your REST API is a layer, and then you have your React application on top of that. When you have your CSS, you have your CSS is concerned with styling. You've got your JavaScript's concerned with interactivity. The HTML is concerned with the structure of the web. So there's a lot of different ways that things get sliced up and broken up, and HTML and CSS and JavaScript is a common way that we refer to, that's a common case of that separation of concerns where they're concerned with different parts. Okay. I think the best interpretation of concerns that I've heard is actually from Uncle Bob, in that he has said the best way to kind of interpret it is, what are your sources of changes? Well, who usually, when you have a problem in your application, whether it be a bug or it's just, hey, you need a new feature, how's that usually coming about? Well, it's usually because of a person. It actually usually reasons and sources of changes, concerns, actually usually you can trace them back to the person that wants that thing. So actually usually you can trace one of the better ways to trace and define concerns is about who could ask for that change. right? So, for instance, if we're talking about the different people that are working on your team, you might have designers, web designers, application designers, UX, and graphic design people, and they will be concerned with how the application looks. So they're concerned with the colors, they're concerned with margin and padding and backgrounds and images and graphic design. Those things all fit into their concern, including animations and the like. Does that make sense so far? So graphic designers is one kind of concern, which encompasses a lot of the UI type stuff. Who else might be interested in changes, right? Where might other changes come from? So Evan, I'm specifically meaning like somebody asking you to change the code, right? Obviously, typically, the people who actually do change the code are going to be your developers and be your developers and your designers, but usually it doesn't start with the developers and the designers. So client is one possibility. Your boss is another possibility. Users are that as well. Those are all possibilities. One question asked in there: who's your boss, right? What kind of changes? Like, what boss are we talking about? Because actually, in the software development world, you generally have kind of more than one boss. So if you're working like, say, fast food restaurants, you really usually just have one manager, and they're kind of over you, and they're managing and telling you what to do. But actually, in the workplace, when we're talking about software development, it's actually quite a bit more complicated than that. So usually several people that are telling you what to do, and telling you what to do for different reasons. So the question of boss is a hard one, and in fact, actually, it could be, but actually, usually your quote unquote boss is not going to be the one that's asking you to do things, which is kind of a weird thing. So usually, and Michael, you asked a good question about the team. Usually, the team is delegating the tasks. Usually, the team is figuring out this person's going to do this and this and this, but actually, usually the team's not setting the actual goals. Usually, most of the team members, most of your developers are not actually setting like the terms of like this is what we're trying to build and the why. That actually usually comes from external to the team. So most of our concerns, most of our requests for change are outside the team. It's usually not within the team that we get those requests. So clients is a good suggestion that happens sometimes, and users is a case as well. Talking about clients, not all businesses have clients, right? So per se, client, when you're talking about the term client, we're usually talking about you're working with a contract or a small group or you're maybe a single solo developer, then you might be working with a client. Larger companies don't work directly with clients oftentimes. Okay, so if you're working in a larger team, you're probably not going to directly work with the client. But what might the client request, right? So let's take an example app. So let's say that you're working with an app, working with a client that wants you to build something for them to sell products on eBay easier. What kind of things, like just throwing things out there, what are some of those things that your client might need or ask for if you're trying to build an app to sell things on eBay? So those are some good suggestions. A good way to break it down and kind of think about it is to think about the workflow. So if you think about like what the sellers do, the first thing that they've got to do is list the item. They've got to list it for sale. And in that process, they usually have to take pictures and update info and set prices and shipping rates, etc. So there's a lot of steps within that. So they have to list the product first. Then eventually you have hopefully a seller comes by and purchases it, at which point then you have to ship it. Once you've shipped it, you got to track it and make sure that it gets there. Oftentimes you'll then have needing to provide feedback for seller feedback on the platform. And then, yeah, after all that's all done, you might aggregate and look at tracking or statistics for a long term, looking at the history of sales. So one way to think about it is you can think about each of those different points in the workflow as different concerns, right? So I might think of the feature, the process of listing as one concern, and I want to keep that within itself. I might have another part about the shipping, which would be another concern, or I might have the tracking part and the review part. All of those could be separate concerns. So you can split it up along the workflow way, but you also can split concerns along the layers. So there's a lot of different ways to track that. So I think as what I was trying to say previously, I think though the best way to think about concerns is who's going to request the change. So thinking about those, we've got graphic designers, which would refer to mostly graphic changes. You've got people like, let's say you are talking to the chief financial officer, the CFO. Well, they're going to mostly be concerned with the economics and the purchasing, and so they're going to be concerned primarily are your sales tax calculations, are they correct? Are your discount calculations correct? Are you calculating all the shopping cart and all those fees in correctly, taxes, etc.? And then also just tracking. They are concerned with tracking things over time, tracking orders over time. So that's what a CFO might be concerned about is largely those sort of calculations, because they work in a more of an Excel spreadsheet sort of world. Then you also have people like the CTO, the Chief Technology Officer. The Chief Technology Officer is going to focus on things like okay, how often is our application crashing, right? How many megabytes in size is the APK the downloading? How are we using bandwidth? How are we using battery life and performance and memory usage and all those kind of things? Like those are the kind of things that your CTO might care about, is those kind of bits. Or what are you paying for hosting charges because you have to host these servers and different things out there. So there's all those kind of different pieces or those architectures. And then you've also got, well, what is the CEO concerned with? Well, the CEO, might be concerned with the marketing. It might be concerned with the face or your brand, the general feel of your application. And so they're going to have different things that they see, whether you're talking to the CEO or whether you're talking to the CTO or whether you're talking to the CFO. They're going to have different feelings and different concerns about your application. Okay, so does that help maybe give some idea of what that term is when we're talking about concerns and in separation of concerns? Again, there are multiple interpretations of that term. So one of the things we're trying to get away with this separation of concerns idea is getting out of the common mistake, the really, really common mistake in Android development, which is to write all of your code in an activity or all of your code in a fragment. Is we want to actually move our code out of there. And so what you're going to see by the end of this process is we go from an activity that had most of the code to an activity that has very little of the code, where most of the code is actually elsewhere, where there's actually very little code in the activity and most of the logic lives in other classes, which also means we have more classes to hold that logic, more than just everything being in main activity. So, part of that shift, both the UI and both the activity and the fragment are very UI focused. They have a strong bind to both the UI and a strong bind to the operating system. So when we extract these classes, they're going to be less concerned or less connected to the Android OS itself. They're going to be a little bit more abstract. And part of that is we, as I say here, we really don't own the implementation of either of those. We don't own an implementation of the activity. We don't own the implementation of the fragment. That's entirely controlled by Google and the device manufacturers and everybody kind of working on the Android OS. So we really need to treat these more like glue and just kind of the definition of the relationship between us and the app, us and the OS. So what we're moving towards is this idea that we want to drive the UI from our data models rather than driving the data models from our UI. Again, this is the switch from imperative thinking, where imperative thinking we think, okay, we do this in the UI, these things happen, and therefore we make a change to the data, yada yada yada, and we're really focusing on kind of keeping all that data in the UI's ownership. And what we're moving to is taking all the data out of the UI, putting in its own container, and then just having the UI listen and watch for changes in that data, or respond to or react to changes in the data. So the data changes and we immediately get an update. So that's kind of where we're going, is transitioning from imperative thinking to responsive or declarative thinking, where you say, hey, this is how I want it to look based on the state. So this is going to help us with things where we persist data and we can transfer data between multiple screens. We can transfer it or keep it around with different things that happen, whether it be screen rotation, whether it be the user leaving the application and coming back. So we can work with those things, and also working with network connections that may be more flaky or not available. So things we want to do there. So here's the kind of overall architecture that they're kind of recommending, and this is the architecture we're trying to move forward with. There's this architecture idea that there are multiple layers. So there's a UI layer on the front, which is the part that user sees. And so that's where in the UI layer, that's where our the activities, our fragments, and our views live. They're only strictly in that layer. We'll also be adding to that layer something called a view model. So the view models will also live up there. You may or may not have a domain layer in the middle, and actually for our programs this semester we won't add a domain layer in the middle. We'll just be using a UI layer and a data layer because we don't really have a need for a domain layer in the middle. So we'll have this is kind of what the user sees versus data layer is down where you're kind of, that's where the data is stored. So the data layer would encompass things like databases. If you have a local SQL database on your device, that would be the part of the data layer. If you've got data that's coming from, say, a remote server, so in our case we're pulling that from the NPR newsfeed, or we're pulling that from the REST API for eBay. If we're pulling that from some other network source, that network source is part of the data layer. That's where your databases and your REST APIs live. And so we need to provide some classes in that level that kind of deal with that communication. But we're going to keep those classes separate from the classes in the UI. Okay. So we're going to create some separation there. So there will be at least two layers, the UI and the layer, and the UI and the data layer. There will also be some sub-separations within that. So there's multiple parts to the UI layer, as well as there's also usually multiple parts to the data layer. Another thing I might mention real quick, if you're doing anything with file I/O, storing things in local files, that local file process would also live in this data layer side. So let's look into a little bit about what's inside of the UI. So the UI, we really break it down into two parts. In the UI, there are UI elements and there are stakeholders. Okay, and so for the UI elements, we're talking about the UI elements are the activities and the fragments primarily, but also in there fits the views. Those are the things that user sees on screen and directly interact with user, versus and animations and all those kind of things would fit in here. Then you also have the state holder, which is where we hold the user state. We want to keep that and keep that separated from the actual UI. It's part of our goal. And so we're going to move that state out of traditionally where we've held it, which is in the views, which is in the activities, and we're going to try to move more of that state out into the state holders, namely into view models. Okay, and so this state holder layer here is really where the view model and the live data classes are that we're going to talk about today. That's where that really lives. Is what we want to talk about is how do we build this state holder, these state holders, so that we can separate it out from the UI. So that's step one, is we're trying to separate those into two pieces, two layers, instead of just having that all in one activity. Also, often going ahead and looking at the data layer is not all one thing. So oftentimes you'll see repositories and then you'll see data sources. So data sources being where the data actually lives. Again, whether that be a database, whether that be a network resource, a REST API, a GraphQL API, local files, those are all data sources. Or it could come from device information, or that will all be data sources. Repository, the idea with a repository is then to bring information together from multiple data sources. So for instance, we might oftentimes happen with local apps. Let's say we've got the news stories, the NPR News Stories project. I can pull those stories from the internet, or I could pull them maybe from a local file. I might decide to save a copy of the stories for offline viewing. And so I have one data source that represents the offline stories or the offline database of products or whatever. And I might also have the online REST API. and I can choose between those based on whether or not there's network connectivity. So a repository's job is kind of to figure out what resource is currently available, which one is correct, and sussing out that difference to keep our offline sources, especially our cache sources, up to date. So a repository works with merging and reconciling and syncing multiple data sources together to produce one source of truth for the user. So that's where that lives in there. For now, I'm going to keep things simple. I won't add a repository to the example project that we're doing. So I'll just be dealing with data sources down here rather than trying to add another level of repositories right now. So we're just going to be dealing with something kind of simplified here, but that oftentimes happens as your applications get more complex. You may have those two layers. That's a good question, Evan. Like, will we ever add repositories? Likely not. Likely getting to the point of repositories is something that I won't necessarily have time to cover that whole process. But it is definitely something that if Android's something you want to learn and work forward through, like repositories is definitely an important part of professional level apps. But on the flip side of it is that we can build apps this semester that meet our needs and meet our objectives without necessarily adding a repository. The main reason that repository comes in is when you're dealing with offline access, where you're saying, I need to be able to use this app both online and offline. And so where we're primarily focused is the online portion of this. So I don't think I'm going to get too much to all of the details and the nitty-gritty of offline usage, and that's where the repository would fit in. So, and I definitely won't be talking about as far as the domain layer goes. So the main thing you want to see there is that down in the data layer, the primary thing we'll be working with is data sources, and up in the UI layer, we're going to split things into UI elements and stakeholders, and we'll subdivide it even further from that too. Okay, so that's the broad overview of what the application architecture is shifting towards. And the main shift there is the separation between data and UI. The next thing we want to look at is how do we actually make this happen? And so remember, what I'm primarily concerned about today is how do we implement that stakeholders side. We'll be looking, when I go to the code example, that one does have a separate data layer, so we'll see how that functions. But the thing I want to focus from the new classes that we need are these ViewModel and the LiveData, which are going to use to implement our stakeholders. Okay, so what is a ViewModel? ViewModel class is assigned to store and manage, as they say, UI-related data in a way that is lifecycle conscious. And what we mean by lifecycle conscious is that activities, for instance, have what we call a life cycle. They can be in a variety of different states over the course of your application running. Okay, so list those off real briefly. When your application starts, when an activity starts, it's going to first be created, and so that goes through the onCreate method. There's then a process of starting it, so it goes to started. It then gets resumed, goes from pause to resumed. So you have an onCreate callback, you have an onStart callback, you have an onResume callback. That's the first way of getting it in. And then when it goes away, it's going to go through being paused, being stopped, and then finally being destroyed. There's a little bit more nuance to how sometimes it may just be paused, sometimes it may be stopped, sometimes it may be destroyed, but that's what we're talking about. There's those series of states when we're talking about lifecycle aware. And so the benefit is that both ViewModel and LiveData are aware of your activity's life cycle. They're able to respond to it, they're able to react to it, and do things as needed, so that they don't cause issues and they're not sticking around with activities that have already been destroyed, etc., etc., etc. So one of the things that the view model really helps with is helping your data, helping your application survive what we call configuration changes, such as rotating the screen. If you rotate the screen from portrait to landscape, then that activity gets destroyed and a new one gets created. And so view models are really helpful as one way, and really the most modern way of doing this, of surviving that change, is saying we can put data in a view model, and the view model doesn't go away when that activity gets destroyed and recreated. So it helps make data survive that transition is one part. And also, the other thing that ViewModel does is allows us to have data that we can access from multiple screens. We can access that ViewModel from multiple different activities, and we can access it from multiple different fragments. And so it provides a good binding layer to get data from one place to the other, but making sure that we're not, again, sending data to activities or fragments that are no longer active or not listening for that data. So in this article, they mention a lot of times the term UI controller. When they say UI controller here, they're talking about activities and fragments. So again, fragments, remember, are basically mini activities. We haven't done anything with fragments yet. Hopefully we'll have a chance to do stuff with fragments later. But that's the gist of it, is to understand as they're mini activities. Jumping over a little bit real quick and kind of looking at an example view model. When we're defining our view models, the first thing we have to do is we have to make sure that they extend the view model class. So that's step one, is whatever you're making in terms of a view model needs to extend the view model class. So here we have my view model extends view model. Inside of this, they have a private variable. So they have a private variable of users. So this view model in particular is tracking maybe a user list. And so you can see list of users. And then that's stored within immutable live data. So we haven't talked about live data yet, but live data will be the container that we use to store and do the communication with different pieces of data that we're going to pass between the model and the data layer, and it's between the data layer and the UI layer. So that's how we get the live data, is this idea that's going to allow us to dynamically update the UI when the data changes. So large in part, our view model will be mostly concerned with all of these live data objects, okay, is mostly what it's going to contain. So it's got a live data for the user list. We can ask for that, and so from the activity we could say, okay, we've got a view model, give me that live data for the users. And also we have a method here called loads users, which we could call to say, okay, go load the data, go load the users asynchronously from, say, the server or the database or wherever else we're pulling it from. That would then update this live data. When the live data updates, then the activity finds out about it, and the activity updates its screen to reflect the new data that's arrived. So that's kind of the idea. So the way we utilize that view model is over in the activity and on create. We're going to use one way to do this is you can use the view model provider. So view model provider, we're providing that this activity. We're saying then give me an instance of my view model class, which I defined up here. So I get that model back. Oftentimes I'll save that model in an instance variable so I can reuse it. And then I can say model.getUsers. GetUsers will return that live data, and then I can observe that live data. So in the activity, I'll be observing that live data for changes, and so we say, okay, this is the lifecycle loaner that you're connected to. So basically what I'm saying with this is observe it as long as this activity is live. So as long as this activity is actually started and running, then we will be observing and getting events for when this data changes. This, by passing this here, it automatically knows, okay, that's an activity. If the activity is destroyed or if it becomes stopped, then I don't need to send that any events. But as long as it's listening, it's going to tell me anytime there are new users. So I get an event. I basically have a callback here where I can say, okay, if we get new users, if the users list changes, then write code here that's going to update the UI. So the UI is going to update with that new list of users from whatever made it change, right? So that might be because you refreshed the list. It might be because you sorted it from ascending to descending. It might be you sorted it by first name, last name, email address, created date, etc. Or you might be filtering it down to just admins or just customers or whatever it may be. Whatever causes a change to that list, the UI just, hey, okay, there's a new list of users. I will update the UI. So that's the kind of idea, is that we're shifting to the activity is going to get this view model and just be listening for events. Just listening for events on the data, and that's going to drastically remove most of the code that we historically have put into the activity. That's going to push most of the code up into the view model that's actually dealing with this data, and so the activity is very skinny and just knows what to do when the data changes, rather than how to change the data itself. Okay. And they mentioned here, so just doing this here, using this view model will now allow it to survive a rotation. So because the activity doesn't get destroyed, when you rotate the screen, the activity gets destroyed, but not the view model. So you can reload that and use the same view model when you come back and create the new activity. So there's an example of that flow here. So for instance, when we're talking about the life cycle of a view model, life cycle of an activity, let's say you start the application or the user comes to that screen, that activity is going to be first. You're going to call on create, you're going to call on start, you're going to call on resume, and at that point the activity is on screen and the user can kind of interact with it. Then at some point the user rotates it from portrait to landscape. That's going to destroy the activity and recreate a new one. In that process, we go on pause, on stop, on destroy, and then on the new activity, we call on create, on start, and on resume. So this is the old activity, and then this is the new activity. And then if that activity were to say be finished, then that activity is going to go through on pause, on stop, on destroy. Finishing, we want to destroy this activity or we're done with it. But notice that view model persists through those configuration changes, persists through that rotation. And at the point where the activity is actually destroyed because of the finish, then we're going to call to onCleared. So if there's any cleanup that we need to do, we do that in onCleared to clean up the view model. Unhook up any listeners, like network callbacks, etc., that we may need, any resources that we may need to unregister when we're done. But that's the kind of the process. The idea is the view model lives longer than the activity or the fragments. We also have an example here of sharing data between two fragments. So in this case, we have maybe what oftentimes happens is you have maybe a list detail sort of layout. They kind of talk about it here. The idea being, for instance, if you have an email client and on a tablet, you might have on the left side, you have kind of a list of your emails. And then you can tap or select an email, and on the right, it would then expand and show you the full contents of the email. Or in an e-commerce application, the list on the left might be products. You click on a product, and over on the right, then expands and shows you the details of that product. You can envision a similar thing with, say, the bug list or other applications. So the important thing is that both sides of that, the side where you're selecting the item as well as where you're viewing the details, both are concerned with knowing which one, both are concerned with knowing which item is selected. And they're both needing to know when that changes. Both of those sides need to know if you select a different email or a different product, and so they need to notice about that. So here we have a view model, and that view model holds a reference to the selected item, and we can call select, change the item to a new one. So this will update the live data, point it to a new item. Or we can get this live data object so we can monitor it. So there's a getter, there's effectively a manipulator here. So what happens over in the two fragments, we have the list fragment. Again, remember, think about these as mini activities. List fragment and the detail fragment. In the list fragment, we're going to listen for when the user clicks on an item. If the user clicks on an item, then we select that new item. Over on the detail view, we observe the selected item, and when the item changes, then we're going to update the detail UI to reflect the new item that you selected. So that's kind of how we would do the communication there. And that's actually turns out to be a lot easier than how historically we've done that communication between the two different fragments. They used to need to know a lot more about, like, hey, they might need to directly have references to each other, or they might need to directly call each other. They might have needed to go through the activity and actually have a reference to the activity in order to do that communication. You also had to know for sure, hey, are those two fragments on screen? Because maybe they're not on screen. Maybe you're in a phone layout and you can only see one or the other. So it deals with a lot of complexities that we previously had to deal with in the activities and in the fragments by abstracting it out. They also mention here something about dealing with loaders, and that specifically has to do with databases and primarily the SQLite database. I'm not going to talk about that here because we're not talking about local databases right now, and that's not our focus. Our focus on these network resources. They also mention that there's some other reading you can do, but the basic idea is with a view model is that we've got this view model class. This my view model here extends view model, and within there are references to live data object. That's first and foremost thing. They also oftentimes have references to your data layer. So oftentimes what we would call your data sources, which make up your data layer, will also live in this view model. And so we'll be watching and connecting to those data sources to turn it into a view model that the front end can observe. So the view model is the layer that the activity directly connects to. That's a layer that the activity directly interacts with. Next up, we're going to talk a little bit about this live data class. So you saw that live data already a little bit in where we talked about the view models, but also we're going to see it here and talk a little bit about more what live data is specifically. So live data is what we call, as I say here, is a observable data holder class. Okay, so what does that mean? It means it's observable. Observable means that you can watch it for changes. It means that whenever changes happen to that data, you get an event. You get an event saying, hey, there's new data. So you can have observers that listen for changes to that data. Data holder meaning that it just is a container for data. It holds a piece of data, it holds a single variable, and then makes that observable. Okay. So unlike if you look at a design pattern book, or you look at observable patterns in Java, those aren't specifically meant to be built with Android, versus this live data class is specifically built for Android. So normal observables the normal designable observable pattern wouldn't be, say, lifecycle aware. But the live data class is lifecycle aware. It is aware when the activities are started or stopped, or the fragments are created or destroyed. So it respects that life cycle in our application. Okay. To make sure, and so there's some mention here about this, about how this functions. So live data considers an observer. So the things that are listening or observing that data, um, they're represented by the observer class, and we also associate with them. We can look at that lifecycle owner and say, are they started or are they in the resumed state? If they're started or resumed, then okay, yes, they listen for events, but if they're not in those states, then they won't get notified about those events. So that means if your screen, if your activity is off screen, or covered by another activity, maybe they're further along in the app, then that activity won't get events related to that, because the user won't actually see any of that stuff. So only send the observers that are active and on screen are the only ones that will get notified. So that's important. So we can register, the way we register an observer is we need to have an object which implements the observer interface, and we also have to have an object that is a subclass or implements lifecycle owner. And specifically, activity already implements lifecycle owner, and fragment also already implements lifecycle owner. So those are the two things we can provide as lifecycle owners. Generally, that's just a matter of passing this when we say observe. So this relationship allows the observer to be removed, so doing automatic removing. So if the activity is destroyed, it just automatically removes the observer. We don't have to worry about cleaning up the observer, which historically has been a problem. Historically, we've needed to do a lot of work in onCreate, a lot of work in onDestroy, or onStart and onStop to try and clean up and manage that life cycle. And that's been a huge pain in the butt and a big source of errors in the Android world. So this helps alleviate some of those pain points. So some of the advantages overall of this live data class is it ensures that at any given point in time, if you implement this correctly, then you can ensure that your UI matches your actual what data is currently, because that is a problem. Like if you write all of your code in the directly in the activity or directly in the fragment, doing things very imperative, it's very easy to accidentally get those out of sync, where the data that it thinks is currently the state versus the data that the user's seeing, those may not match up, or et cetera, et cetera, et cetera. So it helps to keep those two things in sync. What is the status of the view model and the live data in sync with how the UI looks. It also helps working with memory leaks, because again, the historical pattern of doing observable, the standard pattern of doing observable isn't lifecycle aware, which means that if you follow the standard observable pattern well, then things don't get cleaned up. These observers are still out there when your activities get destroyed. So we want to make sure that that's there. Also prevents crashes due to stopped activities or destroyed activities, because there's a lot of things you're not allowed to do, like you're not supposed to access the views of the activities that are destroyed or stopped. You're not supposed to be interacting with them, and that can cause crashes because of different things, or fragments that are destroyed, fragments that are not visible anymore. So that's part of this is avoiding crashes. Not dealing with the manual lifecycle handling, that's a huge part of this, and again goes back to the crashes and memory leaks. And so a big part of this, as you can see, is really about automatically handling the lifecycle, making sure the data is always up to date, making sure we handle configuration changes. The most common configuration change being rotation. But another really common configuration change that we see, and I forgot to mention this earlier, is changing the language, or changing the area where you're at, the locale. So if I, for instance, am in Mexico, then there's different rules about how things should behave. Or if I'm looking at the UI in Spanish, Then there's different, I want to show the Spanish strings and Spanish text, etc. So when you change locales, you change languages on the device, that actually is a configuration change as well. So if I change from English to Spanish, English, French, German, etc., Japanese, that change in language will also trigger a configuration change in addition to, rotation. So there are other things that trigger configuration changes, not just rotations. That's part of why we use that term. So it's changing the device's configuration, as you said. It also just allows for sharing data, sharing resources. Makes it easier to share data from 2 different fragments, 2 different activities. They can see the same data and transfer it back and forth. So how do we work with live data objects? So first thing we have to do is create an instance of the live data to hold our relevant piece of data that we're trying to do. So like what type? Live data is generic, so it can hold like booleans, we can hold integers, strings, objects, arrays, lists, whatever we need to hold in there, it can hold. So we create a live data object, and this is going to be largely done within the ViewModel. Once we are ready to watch that for changes, we'll register observers over in, say, the activity. The activity will register and observe that data, observe that live data, and that's where we're going to do the attachment. And then as the live data changes, that's a lot of those changes will happen over, actually making changes to the live data will happen over in the ViewModel as well. So you see here, they say when you update the data, the value that's stored in live data, it's going to trigger a change, it's going to trigger an event to all of the observers that are registered or attached to that, as long as they are active. So we kind of see another example here. Here's a name ViewModel, which extends ViewModel. It contains a mutable live data, string, current name. Live datas by themselves, regular live datas are read-only. Mutable live datas are editable. And so oftentimes what we'll do is internally to the ViewModel, we'll create mutable live data to store the data, and so that the ViewModel has access to make changes to the live data, but we'll only expose read-only live data. We'll expose them as live data so that we don't want to have the activities directly changing the data. We want the data to be changed by the ViewModel, not by the activity, not by the fragments. So internally we store those member variables in mutable live data, but our getters are going to return them as live data, not mutable live data, which is a really common thing to miss and forget to do. So, and actually they've done it here because this should be live data right here, not mutable live data in this getter. Okay. So that's there, that's there. We look at the activity that's listening for this. So here we've got, all right, in the name activity has a reference to the ViewModel. So we get the ViewModel, we create an observer, and you can see the observer gets the new name anytime it changes. So basically anytime this observer gets an event, it's going to update this text view to that new name. So anytime the name changes, we call this observer, this onChange method. It's going to set the text to the new text, and here's where we're actually setting it up to observe it. So we say get the current name, that returns a live data. We say observe that live data. We're passing in the lifecycle owner, which is this name activity that makes sure that it gets handles that lifecycle properly, and we pass it the name observer. Okay, so the name observer gets called anytime the current name changes. As far as updating the live data, there are 2 ways to update the live data object. Note that it has to be a mutable object. Mutable live data is the only one that either of these methods are available on. You can't call set value or post value on live data, just mutable live data. So on mutable live data, we can call either of those. Set value makes a change to the live data, the mutable live data, but has to be called on the main thread. So you can only call set value on the main thread. Post value, by contrast, can actually be called on any thread. If you call a post value, if you're on a background thread, foreground thread, wherever, it will put that in as an event, and then later it will run the actual firing and triggering of that change on the main thread. So anytime your observers get fired, the observers always get triggered on the main thread, but you can trigger the change by post value from any thread. So I generally just use post value. I generally try to avoid set value to avoid issues of like, oh, well, this turns out it wasn't on the main thread when I expected to be on the main thread. So largely we're going to use post value to make changes, and then we're going to use the observe to see those changes. It's also worth they mention here that you can use live data with Room. Room is a way, an API that Google provides to work with a local SQLite database. So that means that like you can work with a local database should you need it, and work with that live data. And I think that's as far as I wanted to go with the theory. There's some other things in here. They talk about transformers and the like, but that's really outside the scope of what we want to do right now. The main thing you want to know about is just down here, is we can use post value to make changes to the data, and we're going to use observe to watch for changes to that data. Okay. Questions? I got a question in the chat. Let's see if you listen. So the main two methods that we'll be using, again, observe to listen for changes, post value to make changes.